6-7 notes, polygons in the coordinate plane. For this section we're going to need a few formulas. The distance formula, the midpoint formula, and the slope formula. These are all formulas we've seen in first semester. If you need to pause the video right now and copy down these formulas, go ahead and take a minute to do so. In our first example, we're going to plot a triangle in the coordinate plane and determine if it's scalene, isosceles, or equilateral. So our first job is to plot the points A, B, and C. There we go. Scalene, isosceles, and equilateral. Remember, these are ways to describe the triangle in terms of its side lengths. Scalene means the three sides are all different lengths. Isosceles means you have two sides that are the same length, and equilateral, all three sides are the same length. So what we're going to need to do here is use the distance formula to find the length of all three sides. Let's start with segment AB. So I plug in my x1, y1, x2, y2 values into the distance formula and I get this. I carry out the calculation, 4 minus 0 squared, that's 4 squared. 4 minus 1 squared, that's 3 squared. If I square both those numbers, I get square root of 16 plus 9, which is the square root of 25, so the length of AB is 5 units. Now let's find the length of BC. Again, plugging in all my values using the coordinates B and C into the distance formula. Carry out the calculation step by step. You get the square root of 9 plus 16 again, which is the square root of 25, so the length of BC is 5. So far we have two sides that are the same length. So we can rule out scalene. It's not scalene. It's either isosceles or equilateral. Well, let's find the length of the last side, side AC, and see if it's isosceles or equilateral. So again, plugging in your values or the coordinates for point A and point C into the distance formula, carrying out the calculations, we get the square root of 50. Square root of 50, we can break that down. We know how to simplify radicals. That breaks down to root 25 root 2, which is 5 root 2, which is different than 5. It's a little bit bigger than 5. So what type of triangle do we have here? An isosceles triangle, where two sides are the same length. In this next example, we're asked if parallelogram ABCD is a rhombus. First step, plot the points. Now that we have the points plotted, we need to figure out, is this a rhombus? Well, a rhombus, by definition, has 4 congruent sides, and if we recall, one of the properties of a rhombus is that its diagonals are perpendicular. So we could either do the distance formula 4 times and see if all the 4 sides are the same length, or we could simplify it a little bit and just determine if the diagonals are perpendicular. So for this, we're going to use the slope formula. So I'm going to first start by finding the slope of AC. So I go ahead and plug in my values into the slope formula and I get a slope of 5/6. Now I'm going to find the slope of the other diagonal, BD. When I do that, I get -3/2. Now, how do we determine if these are perpendicular? Remember, perpendicular lines have slopes that are opposite reciprocals, or in other words, the product of the slopes should equal -1. That's not the case here. These are not opposite reciprocals, and they do not multiply to give you -1. So in this case, parallelogram ABCD is not a rhombus. Your homework for section 6.7 is on mathexcelforschool.com, due Sunday at midnight.